Hello everybody. This video is a lesson on non-right angle trigonometry. In particular, in this one, we're going to be talking about the sine rule. In this series, we're going to be talking about all this stuff here: sine rule, cosine rule, the area, the formula for the area of a non-right triangle, some applications of trigonometry. We're going to do it in 3 parts. This video is going to be part 1, lesson 1. We're going to be talking about the sine rule, why there's capital letters used, all that kind of stuff. Next one, we're going to talk about cosine rule. And then the area is pretty easy, but some of those applications, those get kind of tricky. So we're going to do that in the 3rd lesson. But we're going to go into the first one here. So our very first question is, why are capitals and lower cases used in these formulas? So if you look, we have capital A, lowercase a, we have capital A, lowercase a, we have capital C, lowercase c. So why is it like that, right? Well, to help you remember why, let's think about what sine, cosine, and tangent are. Those are functions. Functions have an input, which is inside the parentheses, and for sine, cosine, and tangent, the input is an angle. So when you talk about, like this right here, the sine of A, that means this capital A is a letter. And the reason that we have a lowercase letter is because this A here is going to be its opposite side. So the reason we have upper and lowercase letters is because when they're the same letter, we're saying that those things are related, and we're able to do that without showing a picture like you see here. So in the formulas, you see a capital B and a lowercase b in there together in a ratio. That means they're related, right? That's the side and the opposite angle, or the angle and its opposite side, like here. So B is going to be related to B, and A is related to A, and C is related to C. So that's a confusing point to some people, but once I think you see it, you got it, and there's no reason to mess that up anymore, right? We'll see how that rolls, right? But go ahead and take just a quick minute, write down your thoughts on that, see if you can make that understanding permanent. All right, so now we just talked about why the capitals and the lowercase letters are there in the formulas. So now let's move on to the very first version of the sine rule, because the sine rule can be written in 2 different ways. So we're going to talk about the first one. It's this, where the sine is on the top and the side, the lowercase, is on the bottom. If you want to know where this comes from, like this rule right here, this formula, you can click the link here. I'll leave it in the description. You can use your QR code if you're looking on a computer screen. But anyway, here's what this ratio is right here. These ratios right here are the sine of an angle divided by its opposite side. So got to keep that in mind. That's a ratio. These ratios are equal, which makes them proportional, right? So sine of A over A is equal to the sine of B over B. So the ratio of the sine of an angle to its opposite side is equal to the sine of another angle within that same triangle over its opposite side. So why do they use all 3? Because we're going to use 2 at a time, and it doesn't really even matter which one we do. The reason we use all 3 is because it doesn't really matter which pair you have. If you have 2 pairs from a triangle, if you have the side and an angle, they're going to be proportional to any of the other 2 pairs in that same triangle. So that's pretty cool, right? All right, now, in order to use the sine rule, you have to have one known pair. What I mean is you have to have an angle and its opposite side, both of them known, in order to use the formula, right? So let's say we knew 32 and 14. Which side would we have to know if we wanted to find this angle right here? Would it be angle M or angle N? Because a lot of the time what happens is a problem will give you the wrong side, and you have to be really careful. So here in this case, the opposite of this angle is M. M is opposite, so we would have to know this value right here and plug it into the formula just like this right here. So we'd have sine of 32 over 14 equal to the sine of the thing we don't know divided by M. All right, so let's get into an example with some numbers so we can actually see how this formula works. Run through an example, shall we? So here we have this triangle over here. We have the angle marked 100. We have the angle marked K. All right, so just so we know how this formula works, which side would you not need to know? Would it be this one on the, it looks like the longest side? Would it be this side over here on the right or the bottom side? What do you think? Which side don't you need to know in order to use the law of sines to find the missing angle? Yeah, this side right here on the bottom, it's pretty much useless. We don't need it at all. All right, so here's the values. Let's say that the opposite of 100 is 51, the opposite of k is 36. That's actually one of the biggest things you've got to be careful of. When you plug in the values, you have to make sure that the angle on the opposite side are in the same ratio. And then that's going to be equal to the other ratio of the sine of the angle divided by its opposite side. So you plug those in really careful, and then you're going to use inverse operations. We're going to multiply both sides by 3.6. These over here on the right are going to reduce. You got this nonsense over here. Now the part gets kind of ugly on paper. You have to take the arc sine of both sides. That's the inverse function of sine, right? Just like this. We never write this one over here. We just go ahead and write k. And then this, after you write it down, you're going to put that into the calculator. Go ahead and do it. Try it out. Round your answer to 3 significant figures. You're going to get 44.0 degrees. So it works just like that, right? So I think that's pretty much all right. Now, the reason that this very first version is used for an angle is because the angle's in the numerator. And anytime you're solving an equation and it's rational like this, where you have a ratio, like a fraction, if the unknown is in the denominator, it's a lot trickier. And we could do this formula in 2 different ways. You can have it the way we have now, which is best for finding a missing angle, or this way is way better for finding a missing side. So that's our next thing right there. We just saw version 1 of the sine rule, so now let's go and dive into version number 2. Version number 2, you just flip it over, basically, right? It's the reciprocal. You have the reciprocal proportion, so the side divided by the angle of, or the sine of the angle, right? So we flip it over, and that's how we do. All right. This triangle over here, let's say we have side x. We need to know, right, the opposite side. So what's opposite of x? Is it A, B, or C? Which side do we have to know in order to figure that out? Well, the opposite of this side is this angle. So in order to figure out the side x using the sine rule, we're going to have to know this for sure. Have to know this for sure. The other thing we're going to have to know is either, we're going to have to know a pair. We're going to have to either know this angle and this side, or this angle and this side, one of the two. All right, so let's see how that can go wrong real quick, right? What's wrong with this setup? Why would this not work for the sine rule? Because this won't. This will not work for the sine rule. Do you know why? Here's why. Check this out. This angle is opposite of the side mark 7, not 40. So we can't use the angle 40 degrees. It won't work out. We have to figure out this angle. Now, in this example, we could just, all the angles of a triangle add up to 180. So we could just 40 plus 80 is 120. Subtract 120 from 180. We can find out pretty easily that this is 60. It's really, really important. That's why I put this little example in here. This is really important. You have to use the angle and its opposite. Can't use the angle and its adjacent. That wouldn't be sine. So angle and its opposite. All right, so let's go ahead and run through this example. We're going to set it up like this, right? 7 over the sine of 60, because those are angle and the opposite, equals x over the sine of 80, because 80 and x are opposites. This is the angle, that's its opposite side. So you got to make sure you plug things in really carefully. That's probably the second most common place mistakes are made. The other place is actually on the calculator. All right, so we're going to multiply both sides by the sine of 80. These over here are just going to reduce, right? And then over here, we're going to rewrite it like this. So do everything on paper before you plug it into the calculator. Like put everything you can on the paper first and then plug it into the calculator. So now that we have this, we're going to plug that into the calculator. Go ahead and do it now. Make sure you know how these steps work. Make sure your calculator is in degrees. When you do it, you're going to get 7.96. That's rounded to 3 significant figures. It's actually 7.960. I don't remember what else. But anyway, that's it right there. So I hope you're doing well so far with the calculator work. All right. Now let's see. Does that make sense? Should this side be 7.96? Well, this side's 60 and that side, or this angle's 60, its opposite side is 7. 8's a little bigger than 60, so its opposite side should be a little bigger. Remember, the side that's opposite of the smallest angle is the smallest side. The side that is opposite of the biggest angle is the biggest side. Right. Okay, so we've seen two ways to use the sine rule. One, using it to solve for a missing angle. One, using it to solve for a missing side. Take a couple minutes. Think about what you've learned. Write it down. Write down some questions you might have. Give yourself a chance. Like a lot of the time you feel like you got it because you just saw an explanation, but you really don't. You don't really get it. So if you sit there and think about it for a minute and try to run yourself through, you might run into some misconceptions or gaps or stumbling blocks that you have that you might not realize unless you take the moment to think about it and write it down. So go ahead and do that. All right. So if you need more time, you can pause the video, but we're going to move on right now. You ready? Okay. So we just finished this part, the sine rule. So the second part of the sine rule. So now what information is required? Now we did talk about this in detail, but it's worth talking about again, because the trickiest part about using these rules isn't the function of, or using the rule itself and the formula. It's not how you do it, it's when and why. So check this out. To use the sine rule, and this is going to come into play in the future. To use a sine rule, you've got to have a known angle and its opposite side. Have to have that. If you don't have that, you can't use a sine rule. And then you have to have the opposite of the side you're looking for. You have to have the opposite angle, or if you're looking for an angle, you have to know its opposite side. So there we go. All right, now a couple questions for you to close this out. First one, why can't we just use regular old plain sine if you're going to be looking for a missing side or an angle in the examples we did in this lesson? That's the first question. Second one, if you know two of the sides, why can't you just use the Pythagorean theorem to find the other side in the examples that we did here in this lesson? So go ahead and answer those. And, well, I hope you learned a lot, and I'll talk to you later.